All right. On this side of the sheet, what we're talking about here is which substances are reabsorbed from the kidney into the blood. And so what I want to make sure everybody realizes is that all of these substances there should be none or there should be very little in your urine. So if I were to ask you on the quest, what's a substance that I would find in the filtrate at the beginning of the nephron, but that I wouldn't find in the urine that's produced at the end, these are all substances that would answer that question. Now, the first thing are things that are transported via active transport. That means that your body is going to expend energy to move these substances. And the reason it needs to do that is because these won't move naturally. There is more of these substances outside of the nephron than inside. And normally, particles won't move to an area where they're already in high concentration. Things that belong in this category in no real particular order are glucose, sodium, and amino acids. All of those substances require active transport. Active transport is when particles move from an area of low concentration to high concentration, and it requires that you use ATP, cellular energy, for this to be accomplished. It won't happen naturally. Now, the second two things are substances that would be reabsorbed because of passive transport. That means I don't need cellular energy for this to happen. They are going to move because of charge attraction. And so I mentioned to you a couple of negatively charged things that would now be attracted to, say, the positively charged sodium ion. So this is where chloride and bicarbonate ions go, because they are both negatively charged. They'll be attracted to the positively charged substances that I've reabsorbed through active transport. Now, in diffusion, more specifically, we're talking about the osmosis of water. That's a specific type of diffusion. But in diffusion, it's all because of concentration. Water always moves to an area where particle concentration is high. In other words, there's not as much water. And so water is the substance that moves because of concentration gradients. So since all of those other substances have been reabsorbed, now water says, ooh, concentration is higher over there. I'm going to go back to the spot where the concentration is higher. Does anyone want to ask any questions about, what active or passive transport is, or about any of those substances? A word that I used yesterday that isn't on this sheet, but that I'll just mention, is the idea of hypertonic. Hypertonic means more concentrated. And water will always move to a hypertonic area. Now, substances that are secreted by the blood into the kidney or into the nephron, these are substances that should be in your urine. And they should be in your urine in relatively high concentrations. And that's because your body generally is trying to get rid of these substances. So the first three that I'll mention are all the result of deamination, which happens in your liver. They are ammonia, urea, and uric acid. So those are all waste products that your body is making that will be in your urine. So when we start at the beginning of the nephron in Bowman's capsule and blood is getting filtered, of course, some of those substances will be there, But as the filtrate moves through the nephron, we'll keep adding as much of these substances as we can. Now, other substances, for example, would be hydrogen ions. We discussed yesterday how that can help maintain the pH balance in your body. By getting rid of excess hydrogen ions, your body can increase the pH a little bit, make it less acidic. Now, the other two things, because I had them on the word list, you could fit them in. So if we look up at the word list, what I had put, as the example, this is going to look weird, were drugs and histamines here. But there are lots of other things that would fall into this category. So if I just move back down here, just like that, technically from this list, drugs and histamines go here. But in those two spots, I could put anything that is in excess. Anything that there's too much of in your body will secrete into your nephron so it can become part of your urine. Now, no matter what we're doing, all of this secretion happens because of active transport. That means I need ATP. That means I probably need an incredibly large amount of mitochondria to be kicking around so that I have lots of ATP available. Now for the hormones, the hormone that is directly involved in osmoregulation is ADH, antidiuretic hormone. We saw yesterday that it increases the reabsorption of water. So it acts directly on your nephron to make it more permeable to water, so more water is reabsorbed. The indirect hormone is aldosterone. It increases the reabsorption of sodium. And since we know water follows sodium wherever it goes, it will indirectly increase the reabsorption of water. Both of these things would decrease your urine volume. They will make you pee less. There will be less water for you to excrete. Anything that is a diuretic is something that will do the opposite. Diuretics increase your urine volume. And so on this list, I had alcohol as the diuretic substance. Caffeine could also fit there. But the idea is that specifically for alcohol, alcohol inhibits ADH. So it makes your brain not realize that it needs to produce ADH. Now the last thing on this side is asking you about how much is going into Bowman's capsule. So if 600 milliliters of blood is filtered each minute, 120, which is 20%, goes into Bowman's capsule. And that's what I want you to recognize, 20%. About 20% of the blood that's flowing through your kidneys gets pushed by your blood pressure through those capillaries that have pores, and it gets collected in all of the little nephrons that make up your kidney. Of that, only about a milliliter is actually going to become urine because of all of the reabsorption that's going to happen. Reabsorbed. Do you mean the other 80% of the blood? Oh, sorry. When we're talking about blood, if you think about what's happening, so here's Bowman's capsule. It's the beginning of the nephron. And in here is the glomerulus. That's your blood, and it's got capillaries that have pores in it. Not every milliliter of blood can fit through the pores. So some of what's left over would be structures that are too large, like red blood cells and protein. But realistically, I'm not going to push every drop of blood through the pores of the capillary. It could be more depending on blood pressure or even less depending on blood pressure. But in an average person, about 20% of the volume of blood gets pushed through, and the rest of it just continues on, flows around the body, and can come back again and get refiltered. That's per kidney per minute. Yeah. Now that's this side of the page. Does anybody have any questions that they'd like to ask about any of the things that are on this side? So let's flip to the other side of the page. This is where it was like a little story and you just had to fill in the missing pieces of the story. We'll go here. I'll make it so we can see. All right, so on this side, we're filling in the story of excretion. So the very first thing is where I would put metabolic waste. Excretion is when your body has done some sort of chemical reaction, produced a substance that it doesn't need anymore. That's called metabolic waste. The major organ of excretion is your kidney. Other organs of excretion would include your lungs, your intestines, and your skin. If you recall, I showed you how what you are sweating out and what you are peeing out is basically made out of the same stuff. The liver accomplishes the process of deamination, which I mentioned on the other side. That's when amino acids are broken down. So deamination, I'm taking off the amine part of the amino acid. The liver converts amino acids into ammonia or urea or uric acid. And if you recall, there was a little step-by-step thing. Ammonia is really toxic. So to get from ammonia to urea, we add carbon dioxide. To get from urea to uric acid, we just multiply. We add a few pieces of urea together. The kidney is connected to your bladder by a tube called the ureter. Urine exits your body through the urethra. Those two words are incredibly similar, and on a quest, I would definitely make a question where you had to know the difference between them. In the kidney, there are several sections. You have renal cortex, which is the outer layer, the renal medulla, and the renal pelvis. Your nephron is the microscopic filtration unit. Inside the nephron, blood is filtered. The glomerulus is the structure that allows some parts of the blood, like plasma, to pass through, while other things, like red blood cells, and I'll even add proteins here, cannot. Bowman's capsule is the first step in the path of urine. Then it flows to the proximal convoluted tubule. In the proximal convoluted tubule, we reabsorb nutrients. In the loop of Henle, we specifically reabsorb water, or we could put sodium there because both of them are true. The distal convoluted tubule, which is affected by ADH, and then the collecting duct. So if you take a look, the first page gives you some basic things that could go wrong. This first description ends with itis. Anytime you see itis at the end of a word, it means that that structure is inflamed or infected. So nephritis has to do with your nephron. Now this is a really general condition. So it means that some part of your nephron is inflamed or infected. If I was to be a little bit more specific about nephritis, this could often be the reason that something that's abnormal is in your urine. So if I think about damage to different parts of my nephron, different things could be expected in the urine if different parts of the nephron are damaged. So if there is some sort of damage to the blood supply, so the glomerulus, or Bowman's capsule, both of which are at the beginning of the path, here's what I would expect to find. This is the spot where your blood is filtered, and there are some things that are supposed to get through and other things that are not. If there was damage in this area, I would expect to find red blood cells or protein in the filtrate, in what is going into your nephron is going to be part of your urine. So if you ever answered a question, or if you ever had a question where I said, hey, there's protein in this person's urine, what's the problem? One of those structures has some damage to it, or is inflamed, or is infected. Now, if I was to talk about the proximal or the distal convoluted tubule, which I'll abbreviate PCT-DCT, both of those are found in the cortex, so that's the outer layer of the kidney, and so that's why I'm grouping them together. This is the spot where a lot of reabsorption happens. So if there was damage there, I would expect to find more nutrients than normal in my kidneys. So I might have more amino acids, more sodium, more glucose, more than I'm supposed to have because it's not getting reabsorbed the way it's supposed to. If the loop of Henle had some damage, and I'm putting it separate because it dips down into the medulla of the kidney, so that's the sort of middle portion, I would expect to see more sodium or more water than there would normally be in the urine. And so depending on which part of the nephron is actually inflamed, I would expect different results in a urine test. And you'll notice me mentioning urine tests a lot. We're actually going to, tomorrow, spend the class doing a simulated activity where we look at tests that we can perform on urine, because most of the time, that's how we'll determine if someone has a kidney disorder. Now, aside from some part of your kidney being broken, you could have a kidney stone, and I think it was you, Samson, that said you had to pass a kidney stone. So you can attest to the fact that it would be very painful, very, very painful. I put, just for your interest, pictures of what kidney stones could possibly look like. So if you take a peek, some of them could be sort of smooth, some of them could be pokey and sharp. It would hurt for this to pass through the tiny little tubes that make up your kidney. You said you didn't see what yours looked like afterwards, right? No. I think he was probably in all three, pain and agony and misery. I have seen relatively tough men cry because of kidney stones, so I imagine that it is quite painful. And there's different degrees that you can have. Sometimes people would have one kidney stone, or maybe you would have multiple kidney stones at the same time. The idea is they're formed by the precipitation, so that means I'm forming a solid out of something that is usually soluble. So in your urine, you have a bunch of minerals. You have calcium, potassium, sodium. These are all minerals that are kicking around, and usually they're soluble. They've been dissolved, but it could happen that they become solid. I won't go in too much detail here, but you all took Science 10, and one of the things that you had to look at was the solubility table. Not everything makes a soluble compound together. So if, For example, I'll just use this example. OH negative is the hydroxide ion. And that's the ion that you usually find if there is a base around. And so if pH gets upset in a big way, and your body has too much base lying around, this particular ion makes a precipitate with lots of things. Most things are not soluble with hydroxide. Now, this is not the only thing that could possibly happen, but this is an example of something that would make a precipitate. You get tiny stones, and the tiny stones move with your urine. So they would follow the same path as urine does. You would come out of your nephron through the collecting duct, go to your renal pelvis, then go to the ureter, the bladder, and then finally through the urethra. There are surgical options, there are non-surgical options. Usually, though, people end up having to pass the kidney stone, which means it will move through all of the tubes until it finally comes out of your body. Does anyone want to ask any questions about kidney stones? Oh, it's questions for, how old were you when you had this? Was this like recently? No, he doesn't want to say. It's all right. I could tell you, for example, I remember someone that I know having a kidney stone, and I don't think I had ever seen him cry before, ever, in my whole life, until this kidney stone happened. If we go to the next page, or the next slide, this slide and the rest of them all have to do with diabetes and things that we could do to help fix a person who's got kidneys that are not functioning. Now, a lot of you are probably aware of this type of diabetes. Diabetes mellitus is the type of diabetes that is caused when you do not have enough insulin or your body is not responding to insulin. The result is too much blood sugar, and that's what we'll focus on. When there's too much blood sugar, your filtrate now has a really high concentration of glucose. If there's too much sugar in the blood, we're not losing, so we're not reabsorbing enough glucose back into the blood. Since now there'll be lots of glucose left in the filtrate, it will hold water in the urine because now urine will be the hypertonic substance. Normally, all of the glucose gets reabsorbed, and the urine is not hypertonic. It's less concentrated than its environment. But in this case, the urine would be hypertonic, and water always stays where the concentration is higher. The result is increased urine output and definitely dehydration. So actually, one of the tests that would be performed to determine or to screen someone for diabetes is urine output and urine volume. Now, diabetes insipidus, which is another type of diabetes, is not to do with insulin and glucagon like you would think. It is caused by the inability to produce ADH. So this is specifically related to water balance. In this particular type of diabetes, you have large volumes of urine. If you have large volumes of urine, that means that less of it is being reabsorbed. ADH normally would tell your body to reabsorb water. If you have a large volume of water, less water is reabsorbed, but so is less of everything else. Water will move through your nephron and keep some substances with it. So diabetes insipidus is directly related to ADH. Diabetes mellitus is related because the high blood sugar causes you to have high urine volume. You can see that in both cases, you would have high urine volume. And so that's a key characterizing symptom of diabetes. Now, if you flip to the other side of the page, we'll talk about some ways that we could make up for renal insufficiency. So one of the main ways that we would treat someone whose kidneys are no longer functioning is called dialysis. And I'm actually going to talk about two kinds of dialysis. One of them is renal dialysis, and the other one is peritoneal dialysis. The idea in renal dialysis is that we are going to clean the blood in a person whose kidney can no longer do it. It could also mean that you are missing a kidney. So if your kidney was damaged or had to be removed, dialysis could be the answer for you if you have lost a kidney or missing it. Here's what happens. Blood enters the machine from an artery, just like blood enters your kidney through an artery. And it passes through a series of tubes. The tubes are semi-permeable membranes, kind of like how your glomerulus lets some things through but not others. The tubes are then bathed in a dialysis solution that's similar to blood plasma. The idea is that in this dialysis solution, it's clean. It's clean meaning there's no urea, uric acid, hydrogen, or ammonia. The result is that all of that waste will just diffuse out. Since things can move along a concentration gradient from high to low concentration, whatever is high concentration in your blood will naturally move out into the dialysis solution. The cleaned blood is returned to the body through a vein, just like it comes out of a vein from your kidney. So the machine is literally taking the place of your kidney. Blood goes in, gets cleaned, blood comes out. Yes? It's really difficult for a machine to be more efficient than what's naturally there because the machine would constantly have to be adjusted for each individual person who's going there depending on what their blood levels are, whereas your body would adjust itself naturally because you've got the added effect of hormones, so no hormones are in play there. It does a decent job, but people who are on dialysis would have to have it happen sometimes more than once per day, and it takes several hours, like it takes a really long time, whereas your kidneys would be doing it constantly all the time. When a person's on dialysis, unless they want to sit next to the machine all day, their entire blood supply gets cleaned once, and then they leave, go away from the machine, and they come back, and they have to wait for their entire blood supply to get cleaned again. So it takes a really long time. Now the other kind of dialysis is called peritoneal dialysis, and the reason it's called that is because this part of your abdominal cavity is called the peritoneum. So that's the tissue that's holding together the lower part of your abdomen. So basically, we're saying we're putting a bag of dialysis solution into a tube that's attached to your lower abdomen. And so this would be a permanently inserted tube that a person could every once in a while hook the bag up to have the process happen. What happens is you take the dialysis solution and you drain it into your abdominal cavity. So this would mean literally filling up your abdominal cavity with fluid. So not comfortable or preferable as a long-term solution usually. And it's left there for a few hours. During this time, waste diffuses out. The solution will have no waste in it, and so waste will naturally move from an area of high concentration to an area of low concentration. After a few hours, the fluid drains out back into the bag. So this is not as efficient as actually running your blood through a dialysis machine directly. And in both of these things, notice how it's diffusion, not active transport. Your kidneys perform active transport. That means they use cellular energy to get all of the waste out. Diffusion can only help you reach an equilibrium. So when diffusion is the process that's happening, waste will diffuse out until the concentration of waste in your blood and in the solution is equal. So that means you're not actually getting rid of all of the waste at one time. So both of these are definitely less efficient than your actual kidney would be at cleaning your blood. Nader. And you'll notice I picked these questions on purpose because they are things that I would ask you. The first question I asked you to do on page 315 was number 3, where you compare what's in your blood versus what's in your urine. And this is definitely something that I'll ask you on the quest, because I'd like for you to think about what is going to get reabsorbed and what is going to be secreted. So when your blood enters your kidney, and when your urine exits your kidney, there are substances that we would look for. When your blood enters your kidney, you would expect to find urea, uric acid, and ammonia, and I would expect to find all of those substances in my urine. When blood enters my kidney, I would also expect to find glucose, sodium, amino acids, none of which I would expect to find much of in my urine. For glucose, the value is essentially 0. There should be almost no glucose or none at all in your urine. For sodium, sometimes there's a little bit in your urine, especially if you've had a high salt intake that particular day. But you expect to find relatively little of all of those substances in your urine that's exiting. So notice, these are things that are secreted. These are things that are reabsorbed. Now I could add things to this list. I was just giving a sampling here. Under the reabsorbed section, I could also include water. Now I would expect to find water in my urine. If there was no water at all, you wouldn't have liquid urine. It would be a solid paste, and that would be super gross. I remember watching, I think it was The Big Bang Theory, and Howard is training to go to space, and they leave him out in the woods, and he gets dehydrated, and he mentions that he was peeing out a paste, not a liquid, because he was so dehydrated. But you would expect to find at least a little bit of water in your urine, but you would expect to find less, much, much less water in your urine than there is in your blood, because your blood is going to reabsorb most of it. So that leads us to question number 4. What's the difference between reabsorption and secretion? And so I'm going to do this with a picture. If this is blood and this is my nephron, this is secretion and this is reabsorption. It is the direction in which the substance is moving. Is it going from your blood to your nephron, or is it going from your nephron to your blood? Mm-hmm. No, because we are actively transporting sodium, and sodium drags water along with it, so there's definitely less water there in the urine than there would be in the blood because of the active transport that happened before it. Now the other question on this page was about perspiring. What would happen to a person's urine if it was a really hot day and they were perspiring a lot? You would expect to see very concentrated urine. The idea is that it would be very, very yellow. Sometimes it would be so yellow that it would border on looking brown because it's so concentrated. And when we start talking about urinalysis, I'll show you some color descriptions that we could use for urine. Generally, if your urine is a pale yellow color, that's normal. The brighter or darker it gets, it means the more there is in your urine, and that usually means that something is amiss. Now the other page in your textbook where I asked you to look at some questions was page 326. So I'll just pause for a second and give everyone a chance to catch up and to turn there. So number 6 on this page asks you to look at the data and then tell me which substance is secreted and which substance is reabsorbed. So we are comparing plasma, filtrate, and urine. Just so we're clear, plasma is your blood. The filtrate is what's collected in Bowman's capsule. And urine is what exits the nephron after all of the reabsorbing has happened. Yes. Through the collecting duct, which is the last piece. So if I take a look at these substances, here's what I see. Creatine's number is really high over here. When something is higher in the urine than it is in the plasma or the filtrate, that means it is secreted. You didn't even need to know what creatine is to answer this question. You just had to look at the numbers. Since it said 0.01 in plasma, 0.01 in the filtrate, but 1.9 in the urine, that means that your body is secreting it, adding it to your nephron after filtration has happened. Now the second substance is uric acid, which we already know about. Uric acid has similar numbers to creatine. It's low, low, and then very high. So the same thing would be true. It is secreted. That means that your body is adding it to your nephron after the initial filtration has happened. Now the last substance is the bicarbonate ion, HCO3 negative, and its numbers are the opposite. It is high in the plasma and high in the filtrate, but low in urine. So when something is present in your blood and in the filtrate, but then it's no longer there in the urine, this means it is reabsorbed. So this question is an excellent example of data that I could show you. I could show you a table like this with random substances, and if you compare what's in the filtrate and what's in the urine, you could tell me whether they're secreted or reabsorbed. Question number 8 is asking about low blood pressure and kidney function. Please remember that pressure is how filtration happens. If you have low blood pressure, that probably means you have low blood volume. Pressure is how filtration happens, so there'll be less force pushing things through the glomerulus into Bowman's capsule. The other thing is that pressure is related to blood volume. If you have low blood pressure, you very probably have low blood volume. That means there's less water. Question number 9 says, imagine that you are adrift at sea and your supply of fresh water has run out. Explain why you will become dehydrated if you drink the seawater. Now this specifically is a question I always ask my grade 10 class because we talk about concentrations and solutions here. But the idea is that seawater is hypertonic. It has a very high concentration. That means that if you were to drink it, now your body cells are surrounded by a hypertonic solution, and you are going to lose water. Lastly, number 10. And number 10, what a great numeric response number 10 would make. It's fantastic. See, there's 4 people, and then there would be 4 spots, and I could tell you the 4 disorders, and you would match them up. Each of those individuals has a different substance in their urine. And like I said, testing urine is usually how we test for kidney function. So if someone has protein found in their urine, What would be the probable cause for this to happen? Now, protein being in your urine usually means that something happened to the glomerulus. It got broken somehow. And it could happen because of really high blood pressure ripping a hole through it. That would be a really common thing to have happen. And so if you find protein in the urine, what very probably has happened is that there was too much pressure. There are a lot of reasons that there could be too much pressure. If there's too much pressure, it could be because a person weighs a lot. The person could weigh a lot because they're overweight or possibly because they are pregnant. So this is a really common thing to find in pregnant women, is to find protein in the urine because there's so much pressure pushing on the kidneys that things that normally are too small get pushed through because of all of this pressure. Person number 2 had blood. And I'd like to be specific and say red blood cells because there's more to your blood than just red blood cells. There's white blood cells too, which are a lot smaller. If there's blood, that usually means that there is damage. Red blood cells are not supposed to be able to get through the glomerulus into the filtrate. And so technically, the protein and blood thing could be for similar reasons, but usually the blood means there's actual tissue damage. Protein usually just means there's a lot of pressure pushing on the blood and forcing more things through. Blood means that some tissue has actually ripped or torn or been physically damaged. You would be peeing blood. Yep. The third person had glucose in their urine. The most probable reason for that is that this person is diabetic. And the fourth person had white blood cells. Now, white blood cells are the part of your blood that's a little bit smaller. They can fit through the filter, and so it's possible that they would be there anyways. But white blood cells, we'll see in Chapter 8, have to do with infections. And so if there are a lot of white blood cells present, that indicates that there is an infection of some kind. We could measure white blood cell count in someone's blood just generally to see if they're suffering from an infection.